Testing conventional applications. Anomaly for software engineers. Testing presents an interesting anomaly for software engineers who, by their constructive people, testing requires that the developer discard preconceived notions of the correctness of software just developed and then work hard to design test cases to break the software. So, testing instill guilt. Is testing really destructive? The answer to these questions is no. Goal of testing. The goal of testing is to find errors, and a good test is one that has a high probability of finding an error. Therefore, you should design and implement a computer based system or a product with testability in mind. Testability, operability, it operates cleanly. Observability, observability, the results of each test cases are readily observed. Controllability, the degree to which testing can be automated and optimized. Decomposability, testing can be targeted. Simplicity, reduce complex architecture and logic to simplify tests. Stability, few changes are required during testing. Understandability of the design. What is a good test? A good test has a high probability of finding an error. A good test is not redundant. A good test should be best of breed. A good test should be neither too simple nor too complex. Internal and external views. Any engineered product and most other things can be tested in one of two ways. Knowing the specified function that a product has been designed to perform, tests can be conducted that demonstrate each function is fully operational while at the same time searching for errors in each function. Knowing the internal workings of a product, test can be conducted to ensure that all gears mesh, that is, internal operations are performed according to a specification and all internal components have been adequately exercised. Test case design. Bugs lurk in corners and congregate at boundaries. Boris Bezer objective to uncover errors criteria in a complete manner, constraint with a minimum of effort and time. Executive testing. Loop less than 20x. Statement condition statement statement condition. There are 10 to the power 14 possible paths. If we execute one test per millisecond, it would take 3170 years to test this program. Selective testing. Selected path. Loop less than 20x. Internal and external views of testing. Any engineered product can be tested in one of two ways. Knowing the specified function that a product has been designed to perform, tests can be conducted that demonstrate each function is fully operational while at the same time searching for errors in each function. Knowing the internal workings of a product, tests can be conducted to ensure that all gears mesh, that is, internal operations are performed according to specifications and all internal components have been adequately exercised. Internal and external views of testing. The first test approach takes an external view and is called black box testing. The second requires an internal view and is termed white box testing. Black box testing alludes to tests that are conducted at the software interface. A black box test examines some fundamental aspects of a system with little regard for the internal logical structure of the software. White box testing of software is predicted on close examination of procedural details. Logical paths through the software and collaborations between components are tested by exercising specific sets of conditions and or loops. Software testing methods, strategies. White box methods and black box methods. White box testing, glass box testing. White box testing is a test case design philosophy that uses the control structure described as part of component level design to derive test cases. Using white box testing methods, you can derive test cases that guarantee that all independent paths within a module have been exercised at least once. Exercise all logical decisions on their true and false sides. Execute all loops at their boundaries and within their operational bounds, and exercise internal data structures to ensure their validity. White box testing. Statement condition fair statement. Our goal is to ensure that all statements and conditions have been executed at least once. Why cover logic errors and incorrect assumptions are inversely proportional to a path's execution probability. We often believe that a path is not likely to be executed. In fact, reality is often counterintuitive. Typographical errors are random. It's likely that untested paths will contain some. Basis path testing. The basis path method enables the test case designer to derive a logical complexity measure of a procedural design and use this measure as a guide for defining a basis set of execution paths. Test cases derived to exercise the basis set are guaranteed to execute every statement in the program at least one time during testing. The structured con- uh, the structured constructs in flow graph form sequence while until sequence if while until case where each circle represents one or more non-branching PDL or source code statements. Flow graph notation. Areas bounded by edges and nodes are called regions, while when counting regions, we include the area outside the graph as a region. Edge, region. Okay, node, edge, and region. Independent program paths. An independent path is any path through the program that introduces at least one new set of processing statements or a new condition. Example paths from previous graphs: path 1, 1 to 11, path 2, 1 to 2, 1, 2, 3, 4, 5, 10, 1 and 11, path 3, 1, 2, 3, 6, 8, 9, 10, 1 and 11, path 4, 1, 2, 3, 6, 7, 9, 10, 1 and 11. Note that each new path introduces a new edge. The path 1, 2, 3, 4, 5, 10, 1, 2, 3, 6, 8, 9, 10, 1, 11 is not considered to be an independent path because it is simply a combination of already specified paths and does not traverse any new edges. Flow graph notation. Compound logic. A compound condition occurs when one or more Boolean operators, logical or and NAND nor, is present in a conditional statement. Each node that contains a condition is called a predicate node and is characterized by two or more edges emanating from it. If A or B, then procedure X, else procedure Y, and if predicate node A, B, X, Y, X. Okay. Cyclomatic complexity. Cyclomatic complexity is a software metric that provides a quantitative measure of the logical complexity of a program. The value computed for cyclomatic complexity defines the number of independent paths in the basis set of a program and provides you with an upper bound for the number of tests that must be conducted to ensure that all statements have been executed at least once. Cyclomatic complexity has a foundation in graph theory and provides you with an extremely useful software metric. Cyclomatic complexity. Complexity is computed in one of three ways. The number of regions of the flow graph corresponds to the cyclomatic complexity. Cyclomatic complexity Vg for flow graph G is defined as Vg equal to E minus n plus 2, where E is the number of flow graph edges and n is the number of flow graph nodes. Cyclomatic complexity Vg for a flow graph G is also defined as Vg equal to p plus 1, where p is the number of predicate nodes contained in the flow graph G. Cyclomatic complexity. Referring once more to the flow graph in the previous figure, the cyclomatic complexity can be computed using each of the algorithms just noted. The flow graph has four regions: Vg equal to 11 edges minus 9 nodes plus 2 equal to 4, Vg equal to 3 predicate nodes plus 1 equal to 4. Therefore, the cyclomatic complexity of the flow graph is 4. Basis part testing. First, we compute the cyclomatic complexity, number of simple decisions plus 1 or number of enclosed areas plus 1 in the case Vg equal to 4. Cyclomatic complexity. A number of industry studies have indicated that the higher Vg, the higher the probability or errors. Modules Vg module in this range are more error prone. Okay. Basis part testing. Next, we derive the independent path. Since Vg equal to 4, there are 4 paths. Path 1, 1, 2, 3, 6, 7, 8. Path 2, 1, 2, 3, 5, 7, 8. Path 3, 1, 2, 4, 7, 8. Path 4, 1, 2, 4, 7, 2, 4, .7, 8. Finally, we derive test cases to exercise these paths. Basis path testing notes. You don't need a flow chart, but the picture will help when you trace program paths. Count each simple logical test. Compound tests count as 2 or more. Basis path testing should be applied to critical modules. Derive, Deriving test cases. Summarizing. Using the design or code as a foundation, draw a corresponding flow graph. Determine the cyclomatic complexity of the resultant flow graph. Determine a basis set of linearly independent paths. Prepare test cases that will force execution of each path in the basis set. Deriving test cases example. Procedure average. This procedure computes the average of 100 or fewer numbers that lie between bounding values. It also computes the sum and the total number valid. Interface returns average total dot input total dot valid. Interface accepts value minimum maximum. Type value 1 to 100 is a scalar array. Type average total dot input total dot valid minimum maximum sum is scalar. Type is integer. I equal to 1 total dot input equal total dot valid equal to 0 sum is equal to 0. Do while value I क्या चुदी अच्छा मुंह बनती था ये. Oh my goodness. Deriving test cases determine the cyclomatic complexity of the resultant flow graph. Vg equal to 6 regions. Vg equal to 17 edges minus 13 nodes plus 2 equal to 6. Vg equal to 5 predicate nodes plus 1 equal to 6. Determine a basis set of linearly independent paths. Path 1 equal to path 1 1 2 10 11 13 path 2 1 2 10 12 13 path 3 1 2 3 10 11 13 path 4 1 2 3 4 5 8 9 6 path 4 5 1 2 3 4 5 6 8 9 2 path 6 1 2 3 4 5 6 7 8 9 2. The ellipsis following paths 4 5 and 6 indicates that any path through the remainder of the control structure is acceptable. It is often worthwhile to identify predicate nodes as an aid in the derivation of test cases. In this case, nodes 2 3 5 6 and 10 are predicate nodes. Graph matrices. A graph matrix is a square matrix whose size, that is number of rows and columns, is equal to the number of nodes on a flow graph. Each row and column corresponds to an identified node, and matrix entries corresponds to connections and edge between nodes. By adding a link weight to each matrix entry, the graph matrix can become a powerful tool for evaluating program control structure during testing. Graph matrices. To this point, the graph matrix is nothing more than a tabular representation of a flow graph. However, by adding a link weight to each matrix entry, the graph matrix can become a powerful tool for evaluating program control structure during testing. The link weight provides additional information about control flow in its simplest form. The link weight is 1, a connection exists, and 0, a connection does not exist. But link weights can be assigned other more interesting properties. The probability that a link is will be execute, the processing time expended during traversal of a link, the memory required during traversal of a link, the resources required during traversal of a link. Control structure testing. Condition testing, a test case design method that exercises the logical condition contained in a program module. Data flow testing selects test paths of a program according to the location of definitions and uses of variables in the program. Condition testing. Condition testing is a test case design method that exercises the logical condition contained in a program module. The simple condition is a Boolean variable or a relational expression, possibly preceded with a not operator, or a relational expression takes the form E1 relational operator E2. If a condition is incorrect, then at least one component of the condition is incorrect. Therefore, types of errors in a condition include Boolean operator errors, incorrect, missing, extra Boolean operators, Boolean variable errors, Boolean parenthesis errors, relational operator errors, and arithmetic expression errors. The condition testing method focuses on testing each condition in the program to ensure that it does not contain errors. Data flow testing. The data flow testing method selects test paths of a program according to the locations of definitions and uses of variables in the program. Assume that each statement in a program is assigned a unique statement number and that each function does not modify its parameters or global variables. For a statement with as its statement number defs x, a statement s contains a definition of x. Use x statement s contains a use of x. If a statement s is an if or loop statement, its def set is empty and its use set is based on the condition of a statement s. The definition of variable x at a statement s is said to be live at a statement s dash if there exists a path from statement s to a statement s dash that contains no other definition of x. Data flow testing. A definition use du chain of variable x is of the form x s dash, where s and s dash are statement numbers. X is in dfs and use s dash, and the definition of x in a statement s is live at is live at a statement s dash. One simple data flow testing strategy is to require that every du chain be covered at least once. It has been shown that DU testing does not guarantee the coverage of all branches of a program. However, a branch is not guaranteed to be covered by DU testing only in rare situations such as if then else constructs in which the then part has no definition of any variable and the else part does not exist. In this situation, the else branch of the if statement is not necessarily covered by do testing. लूप टेस्टिंग, सिंपल लूप, नेस्टेड लूप, कॉन्केटिनेटेड लूप, अनस्ट्रक्चर्ड लूप। ठीक है। लूप टेस्टिंग, सिंपल लूप्स, मिनिमम कंडीशंस, सिंपल लूप्स, skip the loop entirely, only one pass through the loop, two passes through the loop, m passes through the loop, m less than n, n minus 1, n and n plus 1 passes through the loop where n is the maximum number of allowable passes. Loop testing, nested loops, nested loops, start at the innermost loop, set all outer loops to their minimum iteration parameter values, test the min plus 1 typical, max minus 1 and max for the innermost loop while holding the outer loops at their minimum values. Move out one loop and set it up as in step 2, holding all other loops at typical values. Continue this step until the outermost loop has been tested. Concatenated loops, if the loops are independent of one another, then treat each as a simple loop, else treat as nested loop. And if, for example, the final loop counter value of loop 1 is used to utilize loop 2. ब्लैक बॉक्स टेस्टिंग, रिक्वायरमेंट्स, इवेंट्स, इनपुट एंड आउटपुट। ठीक है। ब्लैक बॉक्स टेस्टिंग also called behavioral testing focuses on the functional requirements of the software. That is, black box testing techniques enable you to derive sets of input conditions that will fully exercise all functional requirements for a program. Black box testing is not an alternative to white box test techniques. Rather, it is a complementary approach that is likely to uncover a different class of errors than white box methods. Black box testing attempts to find errors in the following categories: incorrect or missing functions, interface errors, errors in data structures or external database accesses, behavior or performance errors, and initialization and termination errors. Black box testing, unlike white box testing, which is performed early in the testing process, black box testing tends to be applied during later stages of testing because black box testing purposely disregards control structure. Attention is focused on the information domain. Black box testing, how is functional validity tested? How is system behavior and performance tested? What classes of input will make good test cases? Is the system particularly sensitive to certain input values? How are the boundaries of a data class isolated? What data rates and data volume can the system tolerate? What effect will specific combinations of data have on system operation? Graph based methods. The first step in black box testing is to understand the objects that are modeled in software and the relationships that connect these objects. Once this has been accomplished, the next step is to define a series of tests that verify all objects have the expected relationship to one another. Stated in another way, software testing begins by creating a graph of important objects and their relationships, and then devising a series of tests that will cover the graph so that each object and relationship is exercised and errors are uncovered. To accomplish these steps, you begin by creating a graph, a collection of nodes that represent objects, links that represent the relationship between objects, node weights that describe the properties of a node, for example a specific data value or a state behavior, and link weights that describe some characteristics of a link. Graph based methods, to understand the objects that are modeled in software and the relationships that connect these objects. In this context, we consider the term objects in the in the broadest possible context. It encompasses data objects, traditional components, modules, and object oriented elements of computer software. Object hashtag 1, undirected link. Directed link, link weight. Object 2, object 3, parallel links, node weight value. New file menu select generates generation time less than 1 second, allows editing of is represented as document text, contains document window. New file menu select document window, document text. Attributes, contains start dimension, default setting or preferences, background color white, text color default color or preferences. Equivalence partitioning. Equivalence partitioning is a black box testing method that divides the input domain of a program into classes of data from which test cases can be derived. An ideal test case single-handedly uncovers a class of errors, for example, incorrect processing of all character data, that might otherwise require many test cases to be executed before the general error is observed. Test case design for equivalence partitioning is based on an evaluation of equivalence classes for an input condition using concepts introduced in the preceding section. If a set of objects can be linked by relationships that are symmetric, transitive, and reflexive, an equivalence class is present. Any equivalence class represents a set of valid or invalid states for input conditions. Typically, an input condition is either a specific numeric value, a range of values, a set of related values, or a Boolean condition. Equivalence partitioning. Equivalence classes may be defined according to the following guidelines. If an input condition specifies a range, one valid and two invalid equivalence classes are defined. If an input condition requires a specific value, one valid and two invalid equivalence classes are defined. If an input condition specifies a number of a set, one valid and one invalid equivalence class are defined. If an input condition is Boolean, one valid and one invalid class are defined. Equivalence partitioning. User queries, MOSFETs, output formats, prompts, FK input data. Sample equivalence class. Valid data. Users applied commands, responses to system prompts, file names, computational data, physical parameters, bonding values, initiation values, output data, formatting, responses to error messages, graphical data, MOSFETs. Invalid data. Data outside bounds of the program, physically impossible data, proper values applied in wrong places. Boundary value analysis. A greater number of errors occurred at the boundaries of the input domain rather than in the center. It is for this reason that boundary value analysis has been developed as a testing technique. Boundary value analysis leads to a selection of test cases that exercise bounding values. Boundary value analysis is a test case design technique that complements equivalence partitioning. Rather than selecting any element of an equivalence class, BVA leads to the selection of test cases at the edges of the class. Rather than focusing solely on input conditions, BVA derives test cases from the output domain as well. Boundary value analysis guidelines for BVA are similar in many respects to those provided for equivalence partitioning. If an input condition specifies a range bounded by values A and B, test cases should be designed with values A and B and just above and just below A and B. If an input condition specifies a number of values, test cases should be developed that exercise the minimum and maximum numbers. Values just above and below minimum and maximum are also tested. Apply guidelines 1 and 2 to output conditions. For example, assume that a temperature versus pressure table is required as output from an engineering analysis program. Test cases should be designed to create an output report that produces the maximum and minimum allowable number of table entries. If internal program data structures have prescribed boundaries, for example, a table has a defined limit of 100 entries, be certain to design a test case to exercise the data structure at its boundary. Boundary value analysis. User queries, MOSFETs, output formats, prompts, FK input data, and input domain and output domain. Comparison testing used only in situations in which the reliability of software is absolutely critical. For example, human-rated systems. Separate software engineering teams develop independent versions of an application using the same specification. Each version can be tested with the same test data to ensure that all provide identical input. Then all versions are executed in parallel with real-time comparison of results to ensure consistency. Orthogonal array testing. Orthogonal array testing can be applied to problems in which the input domain is relatively small but too large to accommodate exhaustive testing. The orthogonal array testing method is particularly useful in finding reason faults and an error category associated with faulty logic within a software component. Orthogonal array testing used when the number of input parameters is small and the values that each of the parameters may take are clearly bounded. X, Y, Z, one input item at a time. L9 orthogonal array X, Y, Z. ठीक है. Model based model based testing MBT is a black box testing technique that uses information contained in the requirements model as the basis for the generation of test cases. In many cases, the model based testing techniques uses UML state diagrams and element of the behavioral model as the basis for the design of test cases. The MBT techniques require 5 steps. Model based testing. Analyze an existing behavioral model for the software or create one. Recall that a behavioral model indicates how software will respond to external events or stimuli. Traverse the behavioral model and specify the inputs that will force the software to make the transition from state to state. The inputs will trigger events that will cause the transition to occur. Review the behavioral model and note the expected outputs as the software makes the transition from state to state. Execute the test cases, compute actual and expected results, and take corrective action as required. software sorry architectural design. What is architecture? The software architecture of a program or computing system is the structure or structures of the system which comprise the software components, the externally visible properties of those components, and the relationship among them. What is architecture? The architecture is not the operational software, rather, it is a representation that enables you to analyze the effectiveness of the design in meeting its stated requirements. The considered architectural alternatives at a stage when making design changes is still relatively easy and reduce the risks associated with the construction of the software. Why architecture? The architecture is not the operational software, rather it is a representation that enables a software engineer to analyze the effectiveness of the design in meeting its stated requirements. Consider architectural alternatives at a stage when making design changes is still relatively easy and reduce the risks associated with the construction of the software. Why is architecture important? A representation of software architecture are an enabler for communication between all parties, stakeholders interested in the development of a computer based system. The architecture highlights early design decisions that will have a profound impact on all software engineering work that follows, and as important on the ultimate success of the system as an operational entity. Architecture constitutes a relatively small, intellectually graspable mode of how the system is structured and how its components work together. Architectural description. The IEEE Computer Society has proposed IEEE STD 1471200 recommended practice for architectural description of software intensive system IEEE 00 to establish a conceptual framework and vocabulary for use during the design of software architecture, to provide the detailed guidelines for representing an architectural description, and to encourage sound architectural design practices. The IEEE standard defines an architectural description (AD) and as a collection of products to document an architecture. A description itself is represented using multiple views, where each view is a representation of a whole system from the perspective of a related set of stakeholder concerns. Architectural genres. Genre implies a specific category within the overall software domain. Within each category, you encounter a number of subcategories. For example, within the genre of buildings, you would encounter the following general styles: houses, condos, apartment buildings, office buildings, in industrial buildings, warehouses, and so on. Within each general style, more specific styles might apply. Each style would have a structure that can be described using a set of predictable patterns. Architectural styles. Each style describes a system category that encompasses a set of components, a database, computational modules that perform a function required by a system, a set of connection that enables communication, coordination, and cooperation among components, constraints that define how components can be integrated to form the system, and the semantic models that enable a designer to understand the overall properties of a system by analyzing the known properties of its constituent parts. Centered architectures, data flow architectures, call and return architectures, object oriented architectures, layered architectures. Data centered architecture. Data is stored repository or repository or blackboard. Client software and ठीक है. Data flow architecture. Pipes, filter ठीक है. Pipes and filters. Call and return architecture. Main program, controller subprogram, application subprogram. Layered architecture. Code layer, utility layer, application layer, user interface layer and components. Architectural patterns. Concurrency. Applications must handle multiple tasks in a manner that simulates parallelism. Operating system process management pattern, task scheduler pattern. Persistent data persists if it survives past the execution of the process that created it. Two patterns are common: a database management system pattern that applies the storage and retrieval capability of a DBMS to the application architecture, and application level persistence pattern that builds persistence features into the application architecture. Distribution. The manner in which systems or components within systems communicate with one another in a distributed environment. A broker acts as a middleman between the client component and a server component. Architectural design. The software must be placed into context. The design should define the external entities, other systems, devices, people and that the software interacts with and the nature of the interaction. A set of architectural archetypes should be identified. An archetype is an abstraction similar to a class that represents one element of system behavior. The designer specifies the structure of the system by defining software components that implement each archetype. Architectural context: superordinate system used by target system uses actors, uses peers, depends on subordinate systems. Architectural context: safe home product, internal based system, target system, security function, control panel, homeowner uses sensors uses surveillance function, peers. Component structure: safe home executive, external communication management, GUI internet interface, security surveillance, home management, control panel processing, detector management, and alarm processing. Defined component structure. Analyzing architectural design: collect scenarios, elicit requirements, constraints, and environmental descriptions. Describe the architectural styles, patterns that have been chosen to address the scenario and requirements. Model view, process view, data flow view evaluates quality attributes by considered each attribute in isolation. Identify the sensitivity of quality attributes. Architectural complexity: the overall complexity of proposed architecture is assessed by considering the dependencies between components within the architecture. Sharing dependencies represent dependence relationships among consumers who use the same resource or producers who produce for the same consumers. Flow dependencies represent dependence relationships between producers and consumers of resources. Constraint dependencies represent constraints on the relative flow of control among the set of activities. ADL, architectural descriptive language description language, provides a semantic and syntax for describing a software architecture, provides the designer with the ability to decompose architectural components, compose individual components into larger architectural blocks and represent interfaces, connection mechanism between components. And architectural design method: customer requirements, 4 bedrooms, 3 baths, lots of glass. Architectural design: deriving program architecture ठीक है. Partitioning the architecture: horizontal and vertical partitioning are required. Horizontal partitioning: define separate branches of the module hierarchy for each major function. Use control modules to coordinate communication between functions, function 1, function 2, function 3. Vertical partitioning: factoring, design so that decision making and work are stratified. Decision making modules should reside at the top of the architecture. Decision makers and workers. Why partitioned architecture? Results in software that is easier to test, leads to software that is easier to maintain, results in propagation of fewer side effects, results in software that is easier to extend. Structured design objective: to derive a program architecture that is partitioned approach. A DFD is mapped into a program architecture. The PSPEC is used to indicate the content of each module. Notation: structure chart. General mapping approach: isolate incoming and outgoing flow boundaries for transaction flows. Isolate the transaction center. Working from the boundary outward, map DFD transforms into corresponding modules. Add control modules as required. Refine the resultant program structure using effective modularity concept. General mapping approach: isolate the transform center by specifying incoming and outgoing flow boundaries. Perform first level factoring. The program architecture derived using this mapping results in a top down distribution of control. Factoring leads to a program structure in which top level components perform decision making and low level components perform most input computation and output work. Middle level components perform some control and do moderate amounts of work. Perform second level factoring. Transform mapping: data flow model. Transform mapping. Step 1. Review the fundamental system model. Review and define data flow diagrams from the software. Determine whether the DFD has transform or transaction flow characteristics. Step 4. Isolate the transform center by specifying incoming and outgoing flow boundaries. Step 5. Perform first level factoring. Step 6. Perform second level factoring. Step 7. Define the first iteration architecture using design heuristics for improved software quality. Architectural mapping using data flow. Safe home software. Control panel uses user commands and data. Sensor status. Control panel display information. Alarm type: telephone line, telephone number, tones. Architectural mapping using data flow. Control panel user commands and data. Interact with user password. Start, stop, configure, request, configure system, activate, deactivate system, process password, configure data, configuration information, AND message, valid ID message, configuration data, display message and status, sensors, sensor status, monitor status, alarm type, alarm, telephone line, control panel display, level 1 DFD4, the safe home security function. Architectural mapping using data flow. Configuration information, access against a step format to display, generate alarm signal, dial phone, send sensor, sensor status, sensor ID type, alarm type, telephone number tones. ठीक है. Level 2 DFD that refines the monitor sensor transform. Architectural mapping using data flow. Configuration information, configuration data, sensors, ID type, location, sensor status, read sensor, sensor ID setting, acquire response info, establish alarm conditions, alarm condition code, sensor ID limiting, timing information, list of numbers, select phone number, telephone number, formatted ID type, location, generate display sensor information, alarm data, generate alarm signal, alarm type, setup connection to phone net, tone ready telephone number, generate pulses to line telephone number tones. Level 3 DFD for monitor sensors with flow boundaries. Factoring, direction of increasing decision making, typical decision making module, typical worker module. First level factoring, main program controller, input controller, processing controller, output controller. Architectural mapping using data flow. First level factoring for monitor sensor, the program architecture. The program architecture derived using this mapping results in a top-down distribution of control. Factoring leads to a program structure in which top-level components perform decision-making and low-level component performs most input computation and output work. Middle-level components perform some control and do moderate amount of work. When transform flow is encountered, a DFD is mapped to a specific structure, a call and return architecture that provides control for incoming transform and outgoing information processing. Architectural mapping using data flow. Second level factoring for monitor sensors. Second level factoring is accomplished by mapping individual transforms bubbles for DFD into approach modules within Falana Dimka. Architectural mapping using data flow. First iteration structure for monitor sensor. Architectural mapping using a defined program structure for monitor sensor. And second level mapping.